Hello, welcome to a IGCSE past paper question review, and today we'll be focusing on trigonometry since many people have requested that I should do so. So first off, we're going to start with reviewing the problem here. It's actually a syllabus code of 0606 at math, of course, and then paper 1 variant 2 October November and then 2012, and the question is 6. You can refer to it on other websites as well to see that this question is of course generally on the papers. So we'll start off by trying to deduce what we know from the question itself. Using, as you can see, using sine 15, the degree angle, using sine 15 degrees equals to root 2 over 4 times by root 3 minus 1. So without using a calculator, so this of course sine theta equals to opposite over hypotenuse. So what we see is that probably opposite will be a factor of the root 2 times root 3 minus 1, and then a factor of 4, which is the hypotenuse. So find the value of sine theta in the form of a plus b root 2, where a and b are integers. As you can see, theta is here. So we're going to find the opposite over hypotenuse in the form of a plus b root 2. So we might want to simplify it down if we find the value. So as you can see, of course, when you work with sine like this, it's when you work with ratios, angles like this, it's gonna be we're gonna work on a 90 degrees of a right angle triangle. So what we're gonna do is draw an imaginary down line here, which helps our visualization. So this is 90, and this is both of these are 90. So what happens is that we can infer from the initial one was since sine theta equals to opposite over hypotenuse, and this would be the opposite, and this would be the hypotenuse for this problem. And then since it says that sine 15 equals to root 2 root 3 minus 1 over 4, what happens is that this is going to be true for sine 15. The angle sine 15 is going to be true for any fraction. So if I were to times in any value, say if I were to times in 2 over 2, all this, and it's gonna work, since the fraction is how it works. It doesn't really matter what I put it in, what I times in, as in if I were to times in a conjugate, that will work too, as long as the multiplication divides and equals to 1. So what happens is that if I see the hypotenuse here, we show that it's a 4, and it's essentially a ratio to 4 root 3 plus 1. But I want to get the value of 4 root 3 plus 1 underneath here, so then I would know what the value of the opposite is. So as you can see, the factor of if I would do 4 root 3 plus 1 divided by 4, I will get the scalar multiple I have to multiply with, and which is root 3 plus 1, since I want to get the value of hypotenuse here. So what I do is I times in root 3 plus 1, and then if I go on to put in root 3 minus 1, root 3 plus 1, and then over 4 root 3 plus 1. Then now, as you can see, the hypotenuse is actually equivalent to the magnitude observed in this one, which is 4 root 3 plus 1. Oops, 4 root 3 plus 1, there we go. And then so this value will be the exact value for our hypotenuse, rather than just being a scalar multiple of it. And then if I were to go on to expanding this value, which would be 3, and then bring over 3 root 3, but it's completing the square, so 3 plus root 3 minus root 3 cancels out, and then minus 1, and then 4 root 3 plus 1, which would equal to, since these two cancel out, root 2 root 2 over 4 root 3 plus 1, and then this would be our opposite the value for our opposite. So let's focus on sine theta, or let's say we can simplify it down further. So this is our it doesn't tell much. So this value would be our opposite of this one, opposite here. So 2 root 2 is our opposite. So what we can infer from there is that we want to find the sine theta now. So let's go on and find it. So since sine theta equals to opposite over hypotenuse, as seen here again, we should know that opposite is 2 root 2, since I mentioned before, and then the hypotenuse would be 3 root 2 plus 4. And from here, this is our answer, but for the representative of sine theta in the form of a rational number, but we must it's important that we look back into the question. It says that in the form of a plus b root 2. So what happens that if you want to say represent something as an integer, or say divided by a constant, not a constant, just a whole number, we multiply by the conjugate. So as you can see, the conjugate would be, if it's 3 root 2 plus 4, I want to remove the root 2 here, so I should times it by 3 root 2 minus 4. So then it actually cancels out the root 2's and makes it a whole an integer. So 2 root 2, 3 root 2 plus 4 should be times multiplied by the conjugate, which is 3 over 3 root 2 minus 2. There we go. 3 root 2 minus 4. And then what we notice is that, say 6, 12, and then 8 root 2, and then 3 root 2, 9, and then 18, and then plus 4 plus 12 root 2, and then minus 16, and then also minus 12 root 2, which then of course we know that it cancels out, and then I'm left with 12 minus 8 root 2, and then over 2, which then equals to 6 minus 4 root 2. Therefore our values a and b are this a here, and this is b is minus 4. So this is our answer here that we get from the representative of sine theta in the form of a plus b root 2. And basically this marks off our video on a past paper question review. Thank you.